Is it possible to make an SPI Flash memory transparent to a project? I mean, we have seen in other videos how to use a W25Q flash memory connected to the microcontroller having a single SPI port, and how to create an external loader handling it. We have seen also that, using an external loader, CubeProgrammer handles an SPI Flash having it mapped on the microcontroller address space. A TouchGFX project also uses a mapped SPI Flash memory with the help of an external loader. Can we do the same in a generic CubeIDE project? Can we have an SPI Flash mapped on the microcontroller address space and access it as same as we read the microcontroller internal flash? Yes, or almost yes. In this video we will see that setting up a proper driver and having previously created an external loader for the SPI Flash in our project, we can easily handle data stored on it, moving data through the internal to the external flash in case of a new memory allocation, a new configuration, and accessing data strata on the internal and on the SPI Flash in the same way. As I already have done in other videos, I will use here for my test a system with a display. We will handle pictures to be drawn on the display, saving them on both internal and external SPI Flash. Handling images to draw, we have a need to store, read and move large or very large dataset, easily overriding the microcontroller internal flash size. So, having in mind that all we will do here we could apply to any other data structure, let's go to use an external loader handling images in a CubeIDE project. Here is a project I already set up, handling an ILI 9341 with a Bluepill through my handling library. There are some specific videos in my YouTube channel showing the library and how to set up a project with these displays. I will not get you bored here showing again the microcontroller setup, the SPI port configuration for the display, and the library usage. In case of need, you can refer to the videos and to a specific GitHub page. You can find the related links in the video description. Here you see I ran the display test you already know. Other than the display, you see I added a W25Q64 flash via SPI. Display is on SPI 1, flash on SPI 2. Again I'm using it with my handling library, and again I suppose you are here having previously seen the related videos. Below in the video description you will find the link to my flash handling library also. So the project is set and working. Even if right now the flash memory is just connected and set, not used yet. Now I need to add some pictures to this project. That's not using TouchGFX or other graphics libraries. I just want to directly draw pictures to the display. Having a picture to load into a project and to transfer to a display, we face a new problem. That's before the memory occupation, handling flash memories, external loaders, or anything else in the project. SPI displays we have seen until now need pictures in RGB format, RGB 565, 666, 888, but usually we have pictures in JPEG, PNG, many other formats, but not RGB. We need to convert them. If you have seen TouchGFX, you know that TouchGFX Designer accepts usual picture formats like JPEG, and generating the CubeIDE project, it directly writes pictures in RGB 565 or the other format selected in CubeMX configuration, saving data in constant arrays to directly transfer to the display. But here we are not using TouchGFX. Well, we could create a separated TouchGFX project, set up picture format and display size we need, load the picture we need to convert into TouchGFX Designer, save the project in CubeIDE and grab the corresponding generated arrays moving them to our original project. That works, but it is a very long way. There are many other tools performing this conversion. For instance, there is the online converter available on LVGL website. A good solution I found and I usually use for my conversion is this one. Available on GitHub. On this address. This is a converter that gets a JPEG file and generates the corresponding image in RGB format, creating a header file containing the array storing the converted picture. Let's see how it works. I previously set up my images with GIMP. It is a free package I use to set the picture correction I need. Setting color correction, resizing image, cutting it. I'm working on an ILI 9341, so I'm setting here a 200 by 200 pixel image. Indeed, I usually set up in GIMP pictures in the size needed by the display of the project I'm working on. So, using obviously the package you prefer, generate the picture with the correct size for the display. Now, opening the online converter web page, I select the picture. Here are the conversion parameters. Data in the array will be in hex format and exported in RGB 565. In case you have an ILI 9488 using RGB 666 format, here you will set RGB 888. Now it is RGB 565. Split array in multiple lines, just for an easier file handling in the editor. Data will be in byte format, so endianness is meaningless. And here, in the array definition, I set constant, unsigned 8-bit integer. Clicking Convert, you can see the result of the conversion, and clicking Save as File, you will get it in a header file. Conversion is done. Moving the file directly to the include folder of our project, we could even use it without any change. But this way, depending on how we will use the image in the project, we could have some inaccuracies, like having multiple instances of a variable in the memory. It is advisable to complete this file this way. Copy it into the source folder and rename it, changing the extension as a .c file. So we have a .h file and a .c file. Open the .c one. Remove the defined rows and add a include main.h directive. That is related on how I usually set up my project configuration. Indeed, I usually put all the project library includes in the main.h. Probably I have to create a video about the setup, the organization of a CubeIDE project. I mean, my way to do it. So, having done these changes, save the .c file and close it. Back to the include folder, open the image.h file. Add and include guard. I'm using here the filename _ guard label as a macro definition. Now, as in a header file, it is advisable to leave only the declarations. Delete all the array content and add an external attribute to the declaration. At the end, close the include guard still open. OK. Adding an include to main.age. We can now access to the image anywhere in the project. Going to the main loop, I will draw the picture on the display. Here, before calling the display test, I call a library function to draw the picture, the display_picture function, passing the top left corner position, picture width and picture length, which I set using the macro definition created by the converter, and the pointer to data to write. In this case, the array pointer. Display_picture function is really simple. It sets the display area to fill and transfer the data. Bytes to transfer is picture width by picture length by 2, as RGB 565 uses 2 bytes per pixel. Back to the main, after writing picture, adding a delay to let the image on the display for 1 second, the project is ready. Compiling and running it, it works. Here I see that the picture is stored on the internal flash, and I can do that because the picture is small. With a larger picture, we will run out of available internal flash. Let me set a new picture. I modified the project, adding a full screen picture, a 240 by 320 pixel image. I replaced the previous smaller picture with this one in the main loop drawing. And I remove the previous smaller picture .h and .c file. Compiling the project, we ran out of memory. Image is too large for the microcontroller internal flash. We have to move this constant array to the external flash, and we have to program the external SPI Flash. We could do it creating a separate initialization function which read the constant array and write it into the flash. We could also use CubeProgrammer to flash the memory, previously setting a file containing the array image. We will use a third way, using an external loader plugged into CubeIDE. I already prepared an external loader for this project. I mean for an F103 having an 8 MB flash on SPI1. If you need any detail about the creation of an external loader and about an external loader for small size RAM microcontrollers like the F103, you can get an help in the links you see in the video description. Here is my external loader. I have to move it, to copy it, into the CubeIDE external loader folder. To do that, I go to the Program Main folder. You can reach it left-clicking the CubeIDE program icon and selecting Open File Location. Then go to Plugins and look for an external CubeProgrammer folder. Open it and then Tools, Bin, External Loader. Here is a list of the external loaders provided by ST for the various discovery boards available. I'm used to move these external loaders into a subfolder in order to keep here only the external loaders I use for my projects. So I move here the external loader I prepared. Now, going back to the project on CubeIDE, I go to Project, Properties, Run Debug Settings. I open the run configuration I'm using, double-clicking it. Then go to the debugger and in the external loader definition, in the lower part of the window, click Add and select the external loader added. As we are working on an SPI Flash, as per what we've seen in the other videos about the creation of external loaders, I keep unselected the Verify option. Click Apply and close the windows. OK, external loader is added and enabled. Now I have to inform Linker that we have an SPI Flash available. On my GitHub pages about flash memories and external loaders, there is also a file helping in setting up the linker configuration. It is the program linker include.txt file. Get it and copy it into the project main folder. Open it and open the linker script. From the program linker include.txt file, copy the SPI Flash row and paste it into the memory definition section. That is a declaration that there is a new memory area available. The origin address must be the same as what indicated in the external loader when you created it. And if you don't have specific needs, keep on both the hex value 9 7 times 0. The length field must indicate the flash memory size, again corresponding to what into the external loader, and in this case is 8 MB. Now from program linker include file, copy the ext flash section definition and paste it at the beginning of the section area of the linker script. Here we inform the linker that all the program elements assigned to the ext flash section must be allocated into the memory area called SPI_Flash. Finally, we will copy the attribute string in the commented row and paste it into the variable declaration. Here, as the last attribute before the initialization values. Let's recap what we have done. Here we are telling the compiler that this array must be stored in a memory section called ext flash section. Then we tell the linker that all the variables in the ext flash section must be addressed to the SPI_Flash area. Then, in the memory area definition, we say that SPI_Flash starts from hex 9 7 times 0 and its size is 8 MB. In the external loader configuration, we enable the external loader we previously created, and it will handle the flash memory programming for this address range. So, compiling the program, now I have no errors, and we can see that the constant array was assigned to the SPI Flash. Let's try to add some more pictures. These are the images I created. There are 3 full-screen pictures, their size is 240 by 320 pixels, and then 6 smaller ones, which size is 60 by 60. I already added them to the project, as you have seen I did for the first one. All of them have a section attribute for the Ext Flash section. And compiling the project, we see all the pictures assigned to the external flash. So, we can clearly see the advantages we have using an external loader. I don't have to worry about the SPI Flash organization, where to store a picture, and where start the next free area to store the next array. Linker does that for me. I just indicated the constants I have to store on the external flash, and the linker allocated the arrays on it. I can also clearly change the configuration, moving picture from the external flash to the internal one, and vice versa. For instance, here, I just need to remove the section attribute to a couple of pictures, recompiling the project, and we can see that now these two arrays are stored in the internal microcontroller flash. All the rest is of the external one. Changing again the attribute and recompiling, I change the flash allocation. When we will run the project and we are not yet ready to do it, I could easily test different memory configurations to see which is the best performing one. If I flash a project, let me remark the picture drawing as we are not yet ready to read data from the external flash memory. If I flash a project, you see CubeIDE program both the internal and the external flash. You see the blinking as I'm used to do it on my external loaders. Okay, we have seen that configuring the linker script mapping the external flash on the microcontroller memory address space, and with the help of an external loader we previously made for our project, we can really easily handle SPI Flash, storing data and programming it together with the microcontroller internal flash. But what about retrieving data? Is there a similar easy way to transparently handle data read from flash, regardless if it is stored on the internal or on the external memory? The answer is maybe. That depends on how you organize your project, how you develop your software. If you move through the definition of libraries, handling single project modules, through levels of functions, moving this way, we can make even the data retrieving transparent, setting up libraries that let us forget in future the need to know if the data is on the internal or on the external flash, how to get it, its address on flash, and so on. Let us see how to do it in our graphic library. As we have seen, the function displayPicture easily implements commands that display needs to draw an image. That function refers to a picture stored in RAM, or even on the microcontroller internal flash, as these memories allow to access data directly reading them. That's not the same for an external SPI flash, that has to be reached sending single reading commands on the serial port and waiting for the answer from the flash chip. We know that some STM32s provide a port making a quad SPI memory transparent to the user, to the program. allowing access those memories as if they provide a direct memory access. But this feature is available only on the higher range of the STM32 family. And we are trying here to have graphics on small displays with the simplest STM32s. So we should implement a second function, handling SPI communication to the external flash and transferring data to the display. Or not. We could change the display picture function, making it able to understand if data to transfer to the display is of internal memory or on the external flash, making it able to handle both communication, direct memory access and SPI communication. This way, we could make transparent to the program, to the user, where the data is stored, and how to read the array data. The user could even forget if data is stored inside or outside the microcontroller, just using that function to draw the picture. Let's see how to do it. Display picture receives a pointer to the array to show on the display. This pointer can be an address to the microcontroller RAM area. That's the case of a buffer filled on runtime with the data to draw. In this case, the base address is hex2 7x0. Then, the address can point to the microcontroller internal flash. That's when we are drawing a constant array stored over there. The base address is hex 8 6x0. Otherwise, address points to the external flash mapping area. That if it is a constant array stored on the SPI Flash. In this case, the base address is what we defined in the linker script. In our project, it is 9 7x0. So we can know where the array is stored, easily testing the pointer value. If it is in the range mapping the external flash, we have to read data via SPI before moving it to the display. If not, we can directly access the memory as the function is doing now. Going to the header file of the Flash library, I add a new configuration parameter, indicating the address where SPI Flash is mapped. Avoiding mistakes, I will ask to keep it commented if using Flash not mapped on the microcontroller address space, or if using TouchGFX. Then, copying that macro name, back to display picture, I can add a test on the pointer value, detecting if it refers to the SPI Flash or not. Here I can refer to another available macro, indicating the flash size. If we are inside this range, data to draw is on the SPI Flash. Otherwise, I move data to transfer as before. SPI handling is easy. I just need to read data from Flash, store it into a buffer, and transfer it to the display. I know that you are here knowing that the library I made has a data buffer to smartly use DMA on SPI. Well, there are two buffers to switch and a pointer referring to the currently free buffer. So I subtract the flash memory base address to the received pointer address, getting the real address of data on the flash chip. Then I call the flash reading function, giving the starting address to read, the pointer to the buffer to fill, and the numbers of bytes to read. Then I write data to the display and switch buffer. Good. Now, keeping in mind that the buffer size can be smaller than the array to write, I change these rows into a loop. Transferring single buffers until the whole array is moved to the display. Lastly, I add guards in order to let the function work even when installed in projects without external flash or external loaders, or on touch effects. Okay, now we can use the same drawing function on both cases, on array stored internally to the microcontroller or stored on the external SPI Flash. Let's test it. As you see, I added to the main loop the drawings of the 3 background images and the 6 small images. Good. As you have seen, I can move images from the internal to the external flash, just assigning the attribute to each constant array. Having properly setting up the library, now I have a quite easy project handling. I will update the graphic libraries on my GitHub pages with this improvement. Okay, we have seen that, having available an external loader corresponding to our project configuration, we can in a really easy way handle pictures to draw on a display. That just setting up a simple configuration of linker and of the project parameters in CubeIDE. I know you say that, Handling SPI Flash memories can be simple using external loaders. But this way, we don't have to set up one project. We have two projects to create. Our main project and the external loader project. And you are right. But after some practice and some headaches, I agree, you will see that setting up an external loader is really easy. First of all, set up in CubeIDE your real project. Here you will define the exact port to use for Flash and the pin's position, balancing the global configuration needs you have to satisfy. Then, once your design is stable, create a new project. Just referring to the Flash SPI configuration and maybe a LED available, as a simple indicator of the SPI communication running. Keep low the SPI port speed on the external loader. After all, you don't need it on runtime. It doesn't affect your final project performance. And this way, you will have an easy SPI flash memory handling in setting up and testing the project. That's all. Have fun with your external loaders, displays and pictures. And see you to the next videos. Ciao.